Module 4, Lesson 15. Read expressions in which letters stand for numbers. So we are continuing our exploration of expressions, and we're going to focus on situations in which we have variables. When we say letters stand for numbers, we're talking about variables and how can we read and understand those expressions. Looking at our learning target, I can represent real-life situations using numerical and algebraic expressions. So when we start having letters standing for numbers, we switch over to algebraic expressions. And obviously we are going to have some numbers in some of these. I can statements. I can read expressions in which letters stand for numbers. I can assign operation terms to operations when reading. So I can understand the vocabulary and know what operation it's talking about. I can identify parts of an algebraic expression using mathematical terms for all operations. So I can look and say, oh, this is a product. Oh, this is a sum. Oh, this is a difference. Oh, this is a quotient. Using mathematical terms, proper vocabulary. So here you would want to pause, and you would want to take a moment in your workbook and brainstorm what words let you know that you're performing each of these operations. And I know exponents are just repeated multiplication, but there are some specific vocabulary words that let us know when we're doing exponents. So take a moment, pause, brainstorm. What words do you know that let you know you're performing these operations? And do note that there are some words that can let us know maybe we're performing addition or multiplication, and then we have to do a little thinking to decide. All right, so here are some of the words that I came up with that came out of the math program that go with each of these operations. Go ahead and take a moment, add these into your math workbook if you don't have them. Make adjustments to your notes so that you have this good list of vocabulary words. All right, we're going to look at some examples. So we have an algebraic expression here. We know that the operation is a subtraction operation, and we need to represent this expression using words. Now, one of the most basic ones that students come up with is A minus B. And there is nothing wrong with that one. But there are some other ways that this could be expressed that we are going to encounter. It would be nice if everything in life was just A minus B. But sometimes people will say that we have B less than A. And it might be that I have less than you. And so we might say that I have 5 less than what you have, and maybe you've got 15. For some reason, this expression right here is very challenging for students, which is why I bring this up right at the very beginning. I need you to think about what's happening in this statement. In this statement, we are making a comparison. We have someone, A, who has something, and we have someone else who has less than that person. So we have this person, and this person has less. So person B has less than A, and it tells us how much less they have. 5 less, 15 less, 3 less. So a comparison statement there. So here are a couple of other ways you could write this. So we have A minus B. We can say the difference of A and B, so A minus B. Notice the order in which these are written matches with the algebraic expression. we have A decreased by B. So I have A and I am going to decrease it by an amount. That amount is B. And we also have B subtracted from A. I have A and I'm going to take away an amount, which is B. All right, here we have an x, y. Now when I have two variables written right next to each other, pause and think about what that means for a minute. Hopefully you said, I know what that means. That means I'm supposed to multiply. Excellent. So what are some ways that you could write this multiplication problem using words for operations? Well, I could make it nice and simple, the product of x and y. I could say I've got x multiplied by y. I could say I've got x times y. Three very basic ways of saying I'm going to multiply these two variables together. Ooh, this one's a little bit more complicated. It has two terms in it. So, or two things happening. I've got this multiplication part here, and then I've got the add-on part here. Now, as I look at this problem, it's important that I'm saying I need to do the multiplication first because that's the order of operation. So I need to somehow say that I need to multiply, and once I'm done multiplying, then I need to add this on. So pause for a second, think about how you'd do that. So I could say that I have P, and P is going to be added to, I've got a product of 4 and F. So the way this is written, it says that I need the product of 4 and F, and then I will add on P. So there's my order of operations there. I could say 4 times F plus P, and because we read it left to right, we're going to do this first, and then we're going to do this. The sum of 4 multiplied by F and P. So the sum of 4 multiplied by F, so my first part, when I say sum, I've got add-ins. Sum means I'm adding. What am I adding? 4 multiplied by F. I have the and here. This and is separating. So I've got 4 multiplied by F and P. One of the things we're going to encounter in this lesson is if we're not careful, there's going to be multiple interpretations, multiple ways that people can read these expressions. So it becomes important that we are very thoughtful about how we write theirs, so there's only one way that someone can interpret it. All right, taking a look at D here. So I've once again got a difference, and I've got a D and a B raised to the third power. So I could say D minus B cubed. Now when I read that one, this is where I start to get in a little bit of trouble here. I hear D minus B cubed, which is not the same thing as what's in my expression. So even though I read this left to right, I could be not meaning the same thing. And this is a really tricky thing here. Really have to think through what you're saying. So even though this is on the list, I don't love that one. The second one, the difference of D and the quantity B to the third power. So I've got the and here, I've got the D, and I've got the difference. So I've got D on one side, the other side is B to the third power. Okay, that one starts to feel a little bit better. This is where I really like the less than. B cubed less than D. By writing it this way, I'm saying that I'm going to do the cubing here. So I need B cubed on one side, and I've got the D on the other side, and I need less. So D minus B cubed less than D. And it's in situations like this that using this less than comparison can really provide some clarity. And the more than comparison, looking at part C here, I've got P more than. So I've got a very distinctive P is on one side, and I've got the more than on the other side here, which is the product of 4 and F. So I'm using this middle section here to provide separation between the parts of my operation. All right, looking at another example here. Write an expression using words. Now this one is definitely a little bit more complicated. Got a lot of stuff here. Well, I know I've got the H, so I could say H increased by, or well, I could end with increased by H. There we go, increased by H. So there's my plus H. Now looking at this first part, how can I take and write this out? Well, I know I've got a product. So I've got the product of, now I've got two parts here. I've got a 5 and I've got a u minus 10. So the product of 10 less than u and 5. So I've got 10 less than u, that's my parenthesis part. I'm multiplying it times 5, and then I'm going to increase it by h. So the strategy that I'm showing you here is break this down into smaller parts and think about how you can construct this together so that you have a nice complete statement. So the product of 10 less than u and 5. So the product connects with the and. I know this is a factor and this is a factor. And then I'm going to say increase by h, which is going to be adding. So here's another way you could write it. Add h to the product of 5 and the difference of u and 10. So adding the h, which is what we've got here, saying product of, and here's the and, so 1 factor, 2 factors. 5 times the quantity of u minus 10 added to h. Now this one, it kind of bugs me because I read 5 times the quantity of u minus 10 plus h. It doesn't make clear to me that the h is added on after I have done the multiplying. Now I know that that's really picky, but we need to start thinking about what are we really communicating here. Let's take a look at F. Ooh, I love these. So here I have what looks to be a fraction, and fractions are divisions, so I have a dividend and I have a divisor. And I could write here, find the quotient of 3, so there is dividend, and there's my divisor. The quotient of 3 and the sum of d and f. Three divided by the quantity d plus f. And when we throw in that by the quantity, that becomes a separator. 3 divided by, and I'm saying that afterward I have the quantity that I'm looking for. So I've got a d plus f, and 3 is divided by that. The big takeaway here is there are lots of ways to write these things, but we do have to be very thoughtful about what we're actually saying, and is it confusing? So why would we say, why is 3 divided by d plus f not a correct answer? Why couldn't I say 3 divided by d plus f? Well, 3 divided by d plus f. Ooh. Doesn't exactly work, does it? The 3 is supposed to be divided by all of this, not just this. 3 divided by d plus f would indicate that we divide 3 and d first, and then we're going to add f. But that's not what the expression is showing. We're supposed to add these two together and then perform the division operation. All right, looking at some exercises here. Circle all the vocabulary words that could be used to describe the given expression. Well, I see that I have a product in here, so that'll be multiplication. And I see that I have a subtraction operation here, so I've got subtraction and multiplication. So make sure that you pause, perform the exercises, and then watch the video. Just copying down what I'm doing is not going to provide you a great learning experience. Let's see here. Well, I see that I have a product, 5 multiplied by d. And I see that I have a quotient because I am performing division. Ooh, this one's got a lot going on. Well, I see that I have addition because I have a sum in the center here. I know that I've got subtraction. I know that I've got a product here because I've got some factors going on, but I don't see any division. All right, looking at number 4 here, ABC. Well, this is multiplication. Now, depending upon how I read this, I could say that I have A times more than the product of B and C. So I'm saying take the A and it's going to increase it more than the product of B and C. So this more than is a possibility. It's a stretch, but it's a possibility. But really, the times is probably the best answer there. All right. So here we're actually going to write an expression. So you want to pause the video, try and write this out in words, think about the vocabulary that we've used, look back at some of the examples. How did we construct some of these? How are you making sure that someone who reads this is performing this in the right order? Because we do have order of operations. We have to perform this multiplication first, and then we have to take that away from the 8. 8 minus the product of 2 and g. Okay, so I've got 8 minus, what are we subtracting from 8? The product of 2 and g. I like that one. 2 times g subtracted from 8. This one, although okay, this is what I hear. 2 times g subtracted from 8. So 2 times g subtracted from 8. When I read this second one, that's what I hear. So not loving it. If that's what you wrote, it's okay. But do you see the confusion that could come out of that? Now 8 decreased by g doubled. So I've got 8 decreased by g that has been doubled. Okay. Although on this one you could have 8 decreased by g doubled, so 8 decreased by g doubled. Once again, lots of different ways to do them. I don't want to cause stress and anxiety. Just think through, are you being as clear as you possibly can? If someone else were reading this, would they read it and think this is what I am supposed to be doing? All right, we've got 15 multiplied by a plus c. Well, let's see here. 15 times the quantity of a increased by c. So I've got 15 times a quantity. What is the quantity? A increased by c. Okay. The product of 15 and the sum of a and c. Now, I really like this one, because it's telling me I've got a product, so I know I've got multiplication, and I know that 15 is one of my factors. It says that my other factor is a sum, a plus c. So I really, really, really love this second one because it really helps me separate and see. I don't have that confusion. 15 multiplied by the total of A and C. Okay, so I've got 15 multiplied by something, and it's multiplied by a total of A and C. So once again, very clear with what's happening. All right, take a look at 7. Don't forget, pause the videos, give them a try before you watch what I'm doing. So I've got a sum that will then be divided by a 5. So I've got the sum of m and n, so here is a sum of m and n divided by 5, okay. I could read that one as m plus n divided by 5 though, and that could be a problem. The sum of m and n divided by 5. The quotient of the total of m and n and 5. So I have a quotient, I have a division. I've got the total of m and n and 5. Okay. M plus n divided into 5 equal groups. M plus n divided into 5 equal groups. But I could have m plus n divided into 5 equal groups. Now it's about now that kids in the classroom start to go, well, is there ever a right way to write it? And the answer is, we just have to be as careful as we can, as people who write the expressions and also as people who read the expressions. We have to ask ourselves, what is the reader going to think? And when we read it, we need to ask ourselves, what did the writer want us to think? So this is a communication deal. Takes both parties. All right, so here we go. We've got 8, 9, and 10 coming up. So we've got b cubed minus 18. I love how simple those are. B to the third power decreased by 18. It's a little bit longer version. So pause and think about that one. How can you handle it? We're supposed to do this part first according to the order of operations, and then we're supposed to subtract that from f. So I have f, and it is going to subtract or minus the quotient of dn2. That's a nice clean one. D split into 2 groups and then subtracted from f. So this one, we take D, split it into 2 groups, and then we're going to subtract from f. D divided by 2 less than f. The quotient of u and x, u divided by x. These single step ones here are pretty easy. It's when we start doing things like this where we've got a division and then a subtraction that things start to get a little bit more complicated for us. All right, Peter says 11 minus 3c is 3 times c decreased by 11. Is he correct? So he's saying 3 times c decreased by 11. 3 times c decreased by 11. Is that what this means? I hope you're looking at that and saying, no. He said do the multiplication and then make the multiplication smaller by 11. This problem is saying you've got the 11 and then you need to decrease it by this product over here. He's kind of got it backwards. Peter's not correct because the expression he wrote is in the wrong order. If Peter wanted to write a correct expression and use the same vocabulary words, he would have to write 11 will be decreased by 3 times c. All right, looking at the I can statements. Hopefully at this point you are starting to get into your language arts brain here and you are saying, I can read these expressions. Yes, I need to think about the vocabulary. Yes, I need to think about what is going to come first. One of the tricky parts about math is when we read math expressions, we don't always write them left to right. Sometimes they'll tell us what happens at the end first. Hopefully you are thinking about what the operation terms mean. When I read these words, I have an idea of what operation I'm supposed to perform. I can identify parts of an algebraic expression using mathematical terms for all the operations. So I can look and say, oh, that's a product. Oh, that's addition. Oh, that's subtraction. Oh, that's multiplication. That's an altogether. That's a less than. That's an increase by. That's a decrease. So we can use these mathematical terms to indicate operations. All right, so hopefully you're starting to feel a little more comfortable representing real-life situations using numerical and algebraic expressions. I know in this lesson we haven't had the real-life part, but we are moving towards the real-life part. So that concludes Module 4, Lesson 15. If you need to, go back and rewatch the video. I know that sometimes the lack of an absolute, this is the only way you can write it, is frustrating. But just be patient and do the best you can to express yourself using proper vocabulary. And don't forget to do your exit ticket. And if you need help, ask for it.